It's a crucial part of my life right now.
Okay, I think this is exactly the same directions as your first part of your homework where we left off. So you said I got through 36, right?
Yes.
Okay, so this is the directions then that come right after that. 99% sure. Maybe the second set, but this is one of your sets of directions you're going to see. Everything we did yesterday and the day before, everything was on the unit circle. These, you're not given the angle. You're just given that it's angle U and angle V. So you're not using the unit circle. Anytime you don't use the unit circle is when you use X, Y, and R. If you forget what those are, they are on your formula sheet right underneath your SOHCAHTOA stuff at the very top. Okay? So it says sine is Y over R, cosine is X over R, and it has the equation for R equals square root of X squared plus Y squared. Okay? You see what I'm talking about? Okay. Before you can do these problems, you have to figure out what X, Y, and R are, what they are for U and V. Okay? So if I know U, this is what I know. Sine U is 5/13, cosine V is -3/5, and I know they're both in quadrant 2. They're both in quadrant 2, that means my X is negative and my Y is positive. Okay? So the first thing we do before we can solve is we have to find what are X, Y, and R for these angle U and angle V. Okay, well if you know for U, if you know sine is 5/13, what letter goes with 5 and what letter goes with 13?
Y.
Y is 5 and
R is 13.
R is 13. Okay, the sine is Y over R. So then I use my R equation, R equals the square root of X squared plus Y squared, to find X. So 13 equals the square root of X squared plus 25. Solve for X, you would square both sides. So I would have 169 equals X squared plus 25. Subtract 25, so I have 144 equals X squared. And then how do I get rid of a square? Square root. Okay, so I know X could be positive 12, and it could also be negative 12. How do I know it's negative 12?
Because
in
quadrant 2 it has to be negative.
Good. Quadrant 2, X has to be negative. Good. Okay, then I know cosine V. Cosine is equal to X over R, correct? Okay, so X would be -3, and R is 5. Or R can never be negative, because R is your distance. Alright, so if I want to find Y, I'd have 5 equals the square root of 9 plus Y squared. Square both sides. So 25 was 9 plus Y squared. Subtract 9, so 16 equals Y squared. Square root. Okay, so is Y positive 4 or negative 4?
Positive.
Okay, the bad part is you have to do all this work. The good part is it now works for every problem underneath that set of directions. Okay? So we're going to use all of this for 1, 2, and 3. Is everybody okay on how we found X, Y, and R? Okay, so first thing we're going to do is we're going to find sine U plus V. So now we're going to use your sum and difference formulas just like we did yesterday. Okay, so what's the formula for sine U plus V? Bless you. Sine U,
cosine V
okay?
plus cosine U sine V.
Okay. So then I find out what these are by going over here and looking at them. So I need sine U. Well, I was given to it, but sine is y over r, so 5/13. Cosine V, well, I go to V. Cosine's x over r, so negative 3/5 plus. Okay, cosine U, so if I go to U, what's my cosine? Negative 12/13 is good. And what about sine V? 4/5. Okay, so I would have negative 15 over 65 minus 48 over 65, which equals negative 63 over 65. And that's my answer. Okay, now if you did this in the calculator, you should still get the same answer in the end, but these are probably different fractions because they reduce. Okay. If they reduce, like the first one does. Think you can do the cosine one on your own?
Yes.
Alright, try it. See if you can do it. And then you can check. How'd you do? Still working? Good. Okay, you ready to do secant? Okay, is secant on your paper?
No,
No.
I don't think so.
Okay, so secant, cosecant, or cotangent. Sine, cosine, and tangent are the reciprocals. So if you're given one of those, you do the reciprocal one, and then we're going to flip our answer in the end to match it. Okay, so what's the reciprocal of secant? Which one goes with secant? Cosine. Okay, so what we're going to do is we're going to pretend like this says cosine. We're going to solve it all the way out. But at the very end, we're going to do the reciprocal to actually get our secant. Okay, now, I did this one on purpose for two reasons. It has that, then they have v minus u. So in your formula on your paper, this is your first term, this is your second term. So when I'm doing cosine, this would be cosine v, so that's my first term, cosine u, minus sine
Should
V
be
plus, thanks, sine U. Sorry, it is plus, thank you. Okay, now this one's not that big of a deal because it's cosine cosine times sine sine, okay? But if it's cosine sine, make sure you have them in the right order. Okay, so we're gonna solve this out, and then the very last step to get secant is we would flip it. If you had cosecant, which one would you use? Sine, and what about cotangent? Tangent, okay. Okay, so cosine V is 3/5, cosine U, good. Sine V, sine U, good. So I have 36 over 65 plus 20 over 65, which is 56 over 65. Okay, so since I want secant, we just take that answer and we do the reciprocal to get secant. Okay, so this will now get you all the way through 48. Now we're going to do examples on how to do 56 or 64, which are easier. I think they're easier. Everybody feel all right about this? Okay.
What? Can I go to the office, please?
Yeah.
Okay, cool. I want to go too.
They got little slippy guys.
Oh, yeah. I was like, I guess. Oh, no, we did. Are we going to do that? Sure.
Do you recommend going on, if I have that much room, do you recommend going on the other side for this?
For both of them?
Yeah.
Yeah, probably.
What about if I have this much room?
You could probably fit it.
Just right really little.
I felt like something was like wrong. I didn't realize you got like a slip.
Do you not see them come in here?
Now we're back to turn shoes, erasing and writing.
Her face is like on the board. How am I supposed to see that?
Okay, hey Dad, go to the two.
Okay, this is like section 2, like what you quizzed over, but we're just using the sum and difference formulas to help us verify. So it's like combining. So like, you know when you took the quiz last week, the second part of your quiz where you had to prove the left-hand side equal the right-hand side?
Yeah.
Okay, we're doing that, but now we're using sum and difference formulas instead of using the other 3 ones that we used.
Yay.
Okay? Alright, so if I look at the left-hand side, that's sine and minus, correct?
Yeah.
Okay, so we're going to go to our sine, and we're going to do our minus, which says we're going to do sine of the first, cosine of the second. So I would have sine 3 pi, cosine x, minus, okay, then it says we're going to do cosine of the first, sine of the second, so cosine 3 pi, sine x. Okay, we gotta get this to equal sine. Alright, where is 3 pi located on your unit circle? This is my circle, where would 3 pi be?
At 180.
At 180, okay, what's this point at 180?
Negative 10.
Okay, so this is my x, this is my y, right? Okay, sine is y, so what's the sine at 3 pi?
0.
So this would be 0 times cosine minus, okay, what's the cosine of 3 pi? Negative 1 times sine. So what's 0 times cosine?
Zero.
0. Negative, negative makes a positive, right? Times sign would be plus sign. What's 0 plus sign? Sign. That's what you wanted, right?
Yep.
So you're done. So we're proving, but we're using sum and difference formulas. The next one's a little harder.
Oh, yeah.
Here it is.
Yes.
Yeah, I think I did that right now. Is that why I messed up on my quiz? And then I missed the whole thing. I was trying to figure out why.
Are you good now, though? Okay. Alright, so on the left-hand side on this one, you have two things that have sum and difference formulas, and then they're multiplied together. Okay, so do the adding one first. So, what would that be? Cosine,
Cosine of x, cosine y,
okay,
minus sine x, sine y.
good. Okay, so that's cosine x plus y. Now we have to multiply that by cosine x minus y. So if I do cosine, what's x minus y? What's the formula?
Cosine x times cosine y
Okay.
plus sine x, sine y.
Bracket.
I did brackets, you can use parentheses, doesn't matter.
This is not stupid.
Okay, then what do you do now? Distribute, you multiply, right? Okay, now what's gonna happen when I multiply these together? Okay, so these are gonna become squared. So I have cosine squared x, cosine squared y. What about your middle terms? X, y, but what happens? One's positive, one's negative, so what would happen to them? They cancel. So then I just have cosine squared x, cosine squared y, and then I would have minus sine squared x, sine squared y. Okay, is that what we need for our answer yet?
No.
No. Okay, what do all the x's need to be?
Squared.
Well, they need to be squared, but what trig function? Cosine, and all my y's need to be?
Sine.
So what we're going to do is we're going to replace them by using the Pythagorean identities. I know how much you love those.
Oh yeah, for sure.
Okay, so this would stay cosine squared x, but instead of cosine squared y, what can I replace that has a sign? With your Pythagorean identities.
1 minus sine squared.
1 minus sine squared.
Where is that? Is that?
Okay, so those two things are multiplied together. Then I have my minus sign. Now, what about the second part? I want to change sine squared x. Because I need that to be a cosine.
1 minus cosine squared. Okay, then.
Times sine squared y. You with me?
Yep.
Okay, so then I would have cosine squared x minus cosine squared x sine squared y.
What?
Because I just multiplied this,
Oh,
okay? So I multiply this through. Now I'm going to do the same thing over here. Pay attention because this is a minus sign. So this will become minus sine squared y. What happens to these two minus signs?
They make an addition sign.
Okay. Why do I care that's an addition sign?
because it canceled.
Cancel. I get cosine squared x minus sine squared y, which is
What we wanted.
Answer.
Yay.
good job.
Yes, I'm over.
Sorry.
When you